Imagine flipping a switch and instantly giving a material entirely new abilities, simply by shining light on it. It sounds like science fiction, but in modern physics, this idea has a real name: Floquet engineering. At its core, Floquet engineering is about control. By exposing a material to a perfectly repeating external influence, most often light, physicists can temporarily reshape how electrons behave inside it. And when electrons change their behavior, everything else follows. Conductivity, magnetism, even hints of superconductivity can suddenly emerge. The idea isn't new. Back in 2009, physicists Oka and Aoki proposed that periodic light could dress electrons, creating new, hybrid energy states. But there was a catch. Light interacts surprisingly weakly with matter. To force electrons into these new states, researchers had to use extremely intense, ultra-fast laser pulses, so intense that the material often ended up damaged, overheated, or worse. Floquet effects were real, but fragile and fleeting. Now, a breakthrough led by researchers from OGSD and Stanford University offers a smarter approach. Instead of relying on light alone, they turned to excitons. Excitons are peculiar quantum pairs formed inside semiconductors. When an electron absorbs energy, it jumps to a higher energy band, leaving behind a positively charged hole. The electron and hole remain bound together by strong electric forces, forming a quasiparticle that couples far more strongly to the material than light ever could. This strong coupling changes everything. Because excitons interact so efficiently with the crystal, they can drive powerful Floquet effects using much lower energy. No extreme lasers. No near destruction of the material. Just cleaner, stronger, and longer-lasting control. To understand why this matters, think of a playground swing. Gentle, well-timed pushes can send the swing soaring higher than a single hard shove ever could. Excitons provide those perfectly timed pushes at the quantum level. The result is a promising new pathway toward quantum materials on demand. Materials whose properties can be switched, tuned, and reshaped in real time. Floquet engineering may finally be moving from a beautiful theory toward a practical quantum technology.